Hey guys, in class on Wednesday, we went over number 4 on page 10. We talked through page 12, and that's already linked on the Google slide for today, but we also had questions about number 5 on page 11, so I went through that with them, and I also told them there is a geometric related rate on your first test, so you do need to be very comfortable with them. I'm not going to be putting like the ladder because that's too easy, and I'm not going to be putting one like the FRQ that we did yesterday with the tree because that's a little bit beyond the basics. So we're going to take a look at number 5, page 11, which is a cone. All right, and what's happening is it's filled with water and it's dripping out. And remember, we always draw a really good picture. We put all our information down. They said that the dimensions of the cone, that'd be before it started leaking, is that it's 4 inches tall and a diameter of 2 inches. So they're giving you the dimensions of the cone for a reason. They also said that the rate that the volume is changing, or the rate that the water is dripping out of the cone, was a half, but remember it's leaking. So when an amount is going down, its derivative, or decreasing, its derivative needs to be negative. It then said to find dH dt, the rate that the height is changing at the instant when the level of the water, or the height of the water, was 2 inches. So this is going to leak until that 4 inches becomes a 2 inches. At that time, we're going to stop and we're going to find the rate of change in the height, or the water level. So we always need a formula for what we're working with. In this case, it's the volume of a cone. And for that last, remember, volume of a cylinder is pi r squared h. Volume for a cone is 1/3 pi r squared h. I told them to be careful of just starting a derivative right now, because you would need the product rule, because you have here a function of time and a function of time, and you're multiplying them. But you don't need to, because if you go back up here, this is information about h and v. There's nothing about r. And the reason you were given the dimensions of the cone is so that you could write r in terms of h, because we don't know dr dt. So what we do up here, it's easiest if you were just to say, well, what is the radius in terms of the height? And you can see the dimensions of the cone, that the radius is equal to a half of the height. If we wanted to get it just down to a function of h, we would say the height is equal to twice the radius. So it just depends, r. If it depends which one, based on who you want to keep. I want h because my question's about h, and I was not given a whole lot about r. So the first thing I'll do, I'll clean up that constant out front, and I'm going to replace the r with the 1/2 h, or h halves. That's getting squared times h. I haven't done any calculus yet. I've got a little geometry going up here. Good STEM interpretation of the problem and what a rate is. But I really haven't done any calculus yet, and I'm not going to until I clean it up a little more. So my constant out front would be pi 12ths, because I've got the 3 and then the 2 squared. I also have h squared times h. So this is now the volume as a function of its height. So it's in terms of a single variable, so it makes it easier to take the derivative with respect to time when it's one variable. So we pull the power out front, we get 3 pi 12ths, or pi 4ths. We drop the degree 1 times the derivative of the guts, or the derivative of the inner function, so times dH dt. At this point, we need to fill in everything but dH dt, because that's what we were asked to find. So we must have all the other information. Remember, this was a half as given in the STEM of the problem. We're stopping this when h is 2, so I'll put in a 2 in squared, and I'm in search of the rate of change in the water level. These cancel. To get rid of this pi here, I'll divide by pi, and I end up with negative 1 divided by 2 divided by pi will equal dH dt. And remember, a good label is always worth a point on these. So you take your units for the height of the cone, it was in inches, and you take your units for the change in time, and that was in, I believe, wasn't it, guys, or was it minutes? It was minutes. Oh, cancel that. I felt wrong when I wrote it. Sorry, I don't have the problem in front of me. I was trying to remember all of its details. And that would be your answer. So you need to be comfortable with just sort of, this is what I would call a basic geometric related rate. I won't give you anything nasty. That's it. And then they just worked on the packet for